right, the next special relationship of a quadratic, if you recognize it, it makes factoring super fast. So here's this special relationship is called a perfect square trinomial. And remember, the purpose of a perfect square trinomial is that it's factored to a binomial squared. And this is how you identify a perfect square trinomial. You look at the first term and ask yourself, is that a perfect square? Well, it is. The square root of 9p squared is 3p. Then you look at the third term. Is that a perfect square? It is. It's 1. The only thing left that you have to ask, is that middle term 2 times this? So is that middle term 2 times 3p times 1? Well, 3p times 1 is 3p. 2 times 3p is 6p. So this is a perfect square trinomial. So all you're going to do is take the square root of the first term, take the square root of the third term, and put it immediately in the the one set of parentheses, and then square it. Because what that squared means is, let's ignore the square for just a moment. It really means that, remember, quadratics factor to 2 sets of parentheses. Well, if it's a perfect square trinomial, those 2 sets of parentheses will be identical. Well, just like when you have 3 times 3, you can rewrite that as 3 squared. When you have 2 sets of factors that are identical, you can rewrite it as that set of parentheses squared. So that's it. If you'll take the time when you see a quadratic and you recognize right away, oh, that first term is a perfect square. That term is a perfect square. The only thing I have to check is that middle term 2 times the square root of this times the square root of this? And if it is, then you can just immediately factor it to a binomial squared. All right, that's it.